Welcome to Study Loop.
Hi everyone, thanks for joining me today. What we're going to be looking at is the concept of power dissipation. What we have is a car of mass 1400 kilograms that is starting from rest, going through a displacement cycle of 400 meters. And the x, basically the horizontal motion, is described by this function showed here, where x equals 4000 ln of cosh 0.03t, and t is time and x is meters. And the drag function is given by this equation here, where drag is equal to 0.35 times the velocity squared. So it is a function of velocity. What we're asked to find is the power dissipated by drag at time equal to 10 seconds and 15 seconds. So first thing we're going to do is draw a free body diagram of this car going through its motion. So we have the car here, we have a normal force, the vertical, we have the weight force going directly down. We have this driving force that is pushing the car forward, and we also have this drag force that is acting against the direction of the car. And this is positive for our sign convention. So we know that power is equal to force times velocity. Now the force in this case is our drag force, because we're trying to find the power that is dissipated by the drag force. We know that drag is a function of velocity, so we can actually go ahead and plug in for drag. So we can do 0.35 times v squared times v, and this gives us 0.35 v cubed, and that is the power dissipated by drag. We need to find the function for v. We are given the function for x, so we know that x is equal to 4000 ln of cosh 0.03t. Now the derivative of position with respect to time is velocity. So we can say that velocity equals dx dt, and by taking the derivative of this function, we can say that the velocity is in fact equal to 4000 times sinh of 0.03t all over cosh of 0.03t times 0.03. Further simplifying this, we see that the velocity function is simply 120 times sinh of 0.03t all over cosh of 0.03t. Now remember, recall that power is simply 0.35 v cubed. Using these two equations here, the only input that we need is time, and we're asked to solve for the power dissipation due to drag at t equals 10 seconds and 15 seconds. So we can plug in 10 seconds to solve for the first one, and at 10 seconds we find that the power dissipated due to drag is 14.95 kilowatts, and at 15 seconds the power dissipated due to drag is 45.4 kilowatts. Should go ahead and change this to kilowatts. And that is our final answer.